All right, hello class. This is question number 3 from lesson 5.5, and we're working on all these trigonometric identity formulas, and they give us this equation right here, and we're supposed to solve it in two ways. First of all, graphically, using a calculator. So I've actually already typed it in for you. We can see I typed in sine 2x minus sine x, and we're looking for where that equals to 0. So there's basically a bunch of solutions, one there, one there, one there, one there, and one over here somewhere. Now we're only looking at the interval 0 to 2 pi. So we only go from 0, which is over here, to 2 pi, but we don't include 2 pi. So it's really only this one, this one, this one, and this one. Okay, so let's find out where those are. We can use the calculator, of course, to find them first of all. If I use the 0 function, number 2, I can estimate this one, left bound, right bound, guess. And it gives me right away the solution x equals 3.1415927. And do you recognize that number? I do. I hope you also recognize that number. And we're going to find out if, in fact, pi is one of those solutions. So let's do this algebraically as well. Okay, so next up, let's take this equation. We have to look at our identities. So right away in our double angle identities, we see this here. We have sine 2 theta equals 2 sine theta cos theta. Well, we just plug that in directly. So this part right here, the sine 2x, that becomes 2 sine x cos x. Okay, no problem. And then we still have the minus sine x and the equals 0. Okay, so how do we solve this thing? Well, we need to, first of all, take out the common factor, which is sine x, and then we're left with 2 cos x minus 1 equals 0. All right, so that gives us two equations. The first one is either sine x equals 0, or the other alternative is that, I'll write it this way, 2 cos x minus 1 equals 0, which means cos x equals 1 over 2. So we have two equations. Now, let's start with this left-hand one first. So where is sine x equal to 0? Think about your unit circle. This is the y-coordinate. Y-coordinate. So where's the y-coordinate equal to 0? Right here. And over here as well. So that gives us x equals 0 and pi. Now technically, I could also come all the way back around to here as well, but we know that our interval only goes up to 2 pi and does not include 2 pi. So I'll write that here, not including 2 pi. So what that means is I don't write 2 pi down. It's only these two solutions. That's it. Okay, so that's it. We're finished with that first equation. And we can actually see those solutions over here as well, can't we? There's the 0, and there's the pi. So I'm guessing the next equation, the other side, is going to give us a solution here and here. Okay, let's check. Maybe I'll change my color. And now what do we have? We've got to look at our unit circle once again, looking for where the x-coordinate is equal to 1/2. Okay, so that's going to be this point up here and another point down here. Both of these have an x-coordinate of 1/2. Okay, and what angles are those? Well, this one up here is pi over 3, and this guy down here, let's see, that'd be 5 pi over 3. You can check your unit circle for this. Don't forget, you have that available to you. So just look on your unit circle and look for where the x-coordinate is 1/2. So that gives us x equals pi over 3 and 5 pi over 3. Okay, super. So basically we have our answer. X equals 0, comma, I'll just put them in order here. Pi over 3, comma, pi, comma, 5 pi over 3. Finished. One last little note. It is important that you write this in radians because the interval that they gave us was in radians. So if we write our answer in degrees, it doesn't really make sense because, for example, if this one would be 180 degrees, that does not fall into this interval. So anyways, please just be consistent. That's it. Enjoy.